Capacity planning is the process of aligning available resources with anticipated demand to ensure that organizational objectives can be achieved efficiently. Within the Manufacturing Planning and Control (MPC) framework, capacity management consists of capacity planning and capacity control activities that validate the feasibility of production plans before execution begins. The primary goal is to balance load, representing work requirements, with available capacity, representing resource capability. Too little capacity creates delays, missed deliveries, and customer dissatisfaction, while excess capacity increases operating costs and underutilizes resources. Effective capacity management establishes feedback loops throughout the planning hierarchy, allowing organizations to identify imbalances early and make corrective adjustments before execution is affected. Capacity management presents several challenges because demand and resource availability are rarely stable. Demand may fluctuate because of seasonality, market conditions, promotions, or unexpected customer requirements, while capacity may vary because of maintenance, labor availability, equipment reliability, and process efficiency. Capacity planning, therefore, requires continuous evaluation and adjustment. Service industries face unique challenges because services generally cannot be inventoried. Instead, organizations must design capacity strategies that accommodate demand variability through staffing flexibility, scheduling improvements, temporary resources, and demand management techniques. Hotels, airlines, healthcare providers, and other service organizations frequently use forecasting, overbooking policies, cross-training, and flexible staffing to maintain service levels while controlling operating costs. Capacity Requirements Planning, CRP, is the detailed capacity planning process that validates whether sufficient resources exist to support material requirements planning outputs. CRP serves as the counterpart to MRP and operates at the detailed work center level. The process follows a structured sequence: calculating available capacity, determining required capacity or load, creating work center load reports, identifying imbalances, resolving differences, and validating the operating plan for execution. CRP compares planned and released production orders against available resources and determines whether schedules are achievable. If significant imbalances remain unresolved, organizations may need to modify capacity, redistribute workloads, or revise production priorities to create a feasible operating plan. CRP relies on several important inputs to calculate capacity requirements accurately. Primary load inputs include open production orders, scheduled receipts, planned order releases from MRP, firm planned orders, rework, prototypes, scrap allowances, maintenance activities, and past due orders. Additional capacity-related inputs include routing information, work center data, shop calendars, lead times, efficiency rates, utilization rates, and resource availability. Routings define the sequence of operations and the resources required to manufacture products. Accurate data is essential because even small errors in routing, capacity, or inventory information can create unrealistic schedules and inaccurate workload projections. Effective CRP depends on maintaining high-quality planning data throughout the manufacturing system. Capacity can be measured in several ways depending on planning objectives. Theoretical capacity represents the maximum output achievable under ideal conditions, without interruptions. Demonstrated capacity reflects actual historical performance achieved under normal operating conditions. Available capacity considers scheduled work time and resource availability, while rated capacity adjusts available capacity using efficiency and utilization factors. Efficiency measures actual output compared with standard output expectations, while utilization measures actual productive time relative to available time. These metrics help planners understand the true capability of resources and provide realistic capacity estimates. Evaluating different capacity measures improves planning accuracy and supports informed decisions regarding staffing, equipment investment, and production scheduling. Load calculations translate production requirements into resource requirements over defined time periods. Load is generated from planned and released orders and is commonly expressed in labor hours, machine hours, or other resource units. Simulation and modeling techniques help planners evaluate alternative scenarios before implementation. CRP can be used as a simulation tool to assess the impact of changes in lot sizes, routings, production priorities, staffing levels, and other planning factors. Modern systems increasingly incorporate advanced analytics, artificial intelligence, cloud-based planning platforms, and real-time equipment data to improve forecasting accuracy and planning responsiveness. These technologies enable organizations to evaluate multiple alternatives and identify the most effective solutions before operational problems occur. Balancing capacity and load is a central objective of detailed scheduling. When demand exceeds capacity, organizations may increase capacity through overtime, additional staffing, equipment expansion, subcontracting, outsourcing, or schedule adjustments. When excess capacity exists, organizations may reduce capacity, reassign workers, perform maintenance activities, or increase workload through promotional activities and additional production. Capacity cushions, also known as safety capacity, provide protection against uncertainty by reserving resources to absorb unexpected demand or operational disruptions. Planned downtime for maintenance, training, and other activities must also be incorporated into capacity calculations. Effective balancing ensures stable operations, realistic schedules, and reliable customer service, while minimizing unnecessary costs and resource inefficiencies. Labor scheduling and staffing decisions play a vital role in creating viable production and service schedules. Workforce availability, skill levels, productivity, shift patterns, cross-training capabilities, and labor regulations all influence capacity planning decisions. Organizations must ensure that staffing levels support projected workloads while controlling labor costs and maintaining service standards. In manufacturing environments, labor schedules are coordinated with production plans, machine availability, and maintenance activities. In service industries, staffing flexibility often becomes the primary mechanism for balancing capacity and demand. Through integrated capacity planning, CRP analysis, load balancing, simulation, and workforce management, organizations create production and service schedules that support operational objectives, improve resource utilization, and enhance overall business performance.